Hello. Um, that is not a very funny joke, was it? Right. So let's uh, welcome everyone. I don't know how good a mood you are currently in, but if you are from the future in the year 2026, I hope you are in a better mood. If you are watching this one day before the senior 2026, I hope you are feeling optimistic. For everyone that just took the SMO. Well, um, here we are, right? Yeah, so I usually am putting this off, but then every time I put this off, it doesn't really, you know, work anyway. And so let's talk about cutoffs, right? Let's just talk about our cutoffs because we are all thinking of that, right? Uh-huh. Well, that's, okay, I'm not going to throw you, right? All I'm going to say now is that before the review and after the review, our opinions may change quite a lot. The reason is because this paper is full of ways you can make careless mistakes, right? It's full of ways that we can make a lot of errors on questions we got correct, or rather we thought we got correct, and therefore whatever scores you're hearing around are unlikely to be exactly accurate. So it is very hard to say what will happen, but fine, let me just so this is what I think. Okay, I'm not going to beat around the bush. Uh, I think the cutoff will go up a bit, but you may not feel the paper is easier. And the reason why I am saying that right now is that I think that um, if you were to look at the 15 easiest questions from this year, it is easier than last year. If we were to look at all 25 questions, it is harder than last year. And so depending on what you are aiming for, you have a very different opinion of how difficult the paper was. And so if you are talking to some of your friends, if your friend is aiming for a different score from you, they may have a totally different commentary from you. But if you're saying, is it easier than the years other than last year? No, it is still harder than years before that. Now, whatever you have, if the visual quality seems not so good, that is probably for you to adjust your uh, YouTube video quality. I know my laptop is not the greatest piece of hardware on earth, but it is going at 60 FPS, so it's not supposed to be too choppy. If it's too choppy, if the visuals are too bad, then that's probably on the YouTube side. Right. So the plan for today is review is as per you have seen all the previous years. So I'll split it into several parts. I'll probably go through 1 to 10 as the first section. That is also the section where most of your marks would likely have come from. I'm not saying that those are all easy. I'm just saying most of the easy questions can be found in the first 10. And this is generally true for the SMO senior, at least in recent times. Okay, and then after that, we will split the other 15 into 2 or 3 portions depending on what time it is then. My senior review is here first because I would like you to have some time to settle down if you're taking open tomorrow, okay? So please don't get too traumatized. Do get some rest if you're taking open tomorrow. If you took junior and you're just here to say hello, this is senior. This is not junior. Please do not get a shock. And this is not talking about cutoffs for junior. We'll talk about that later on. Okay, so enough talking. Let's get to the questions proper. Question 1. The roots of x squared plus ax plus b equals to 0 are a plus b and b minus a, where a is not equal to b. Find the value of a minus b. this is standard Vietas. As long as we are not too attached to the minus b over a, because that will confuse us. But if we know what the positions are, the sum of roots is going to be negative a, and I'll pause here because this already tells me that 2b equals to negative a is negative 2b. So I can put this straight into here. Sorry, this is minus b and 3b and minus 2b. And so the other one, which is the product of roots, will just be this. Now, a is not equal to b, so we can cancel off the b since it is not 0. If a and b are both 0, everything's the same. That is not going to satisfy this. And then a is 2/3, a minus b is what? Now, I often do advise when we do the papers to look through the entire paper first, just flip through it before you start, because the first few questions may not be the easiest. I think for this case, this year, you will end up still doing it in order for the most part, right? At least for the first 10. Okay. Question 2. I hope I typed this correctly. So I typed the questions myself, hence I always need to check whenever there are these annoying algebraic expressions that I did not mistype something. And this year there were quite a lot of things that could be mistyped. So I think this is okay though. This is also not that bad because it is kind of telling you with the right hand side that it's log base 2. So we just need to do a change of base to make everything into log base 2. So the first one, log 2 of 2 to the 2025 is 2025. So that whole thing cancels out. And you get log 2 of square root 2025 on the left. On the right, you have got 2 over a log. When you take the reciprocal of a log, it just swaps the order. Okay, and then the 2 moves in as a power. And then it combines by your product rule. This is, of course, the same as square root 2025 cubed, which is 2025 to the 3 halves. So answer is C. Okay. Question 3. Quadratic in sine x is still a quadratic. The options here are kind of nice because if you were about to fall into a trap, the options here would help you to avoid that trap. So at least that's good. We complete the square. And now you want the maximum possible, so you want this to be big. You ask yourself, when is it the largest? And if you accidentally thought it was sine x equals to 1, that will be none of the options, and you'll realize that, oh no, the best is actually when sine x equals to minus 1, because that will give you the largest magnitude. So answer is B. Now I'm relatively speed running the front bit because For anyone that realistically wants to, let's say, attempt the questions behind with enough time, you would have probably moved through the front pretty fast. But this is all with the caveat that if you are aiming for anything that is not around to cutoff, you can take your own sweet time on the first 10 questions. If it took you 1.5 hours of just focusing on the first 10 questions and you did, let's say, 8 of them, you can be pretty happy with the outcome, even though that does not sound like a very efficient speed. Question 4. Simple answer. Do you know what the co stands for in cosine? If you do, then you will straight away realize what's happening here. Right, the co in cosine stands for complementary. And of course cosine, right? So it's literally the complementary angles sine. That's where the word co in your cosine comes from. So, with a lot of trigo identities, this is the one you don't need to remember. You just know the name. Cosecant is secant of the complementary angle. Cotangent is tangent of the complementary angle. And so therefore, this is a very quick reminder that these are actually equal to each other. And so these two are the same, and your answer is 1. Okay. Finally, question 5. Finally for the MCQ. I would normally be saying at this point, don't use calculus. We do not need calculus for SMO Senior. It is only tested in SMO Open, but that will be famous last words. So let me rephrase that too. Don't use calculus because almost certainly SMO Senior is not going to test calculus, but certainly they're not going to test you boring calculus. And so instead, this is just a quadratic thing. Quadratic thing doesn't mean that you want to make the top big and put x equals to 0. Sorry, no, make the top small, put x equals to 0, or make the bottom small. Like, it is not certain. What we will actually do is that we can divide the top and bottom by x squared. And I want to complete the square below. But the meaning of complete the square is that I want a constant to be left over. So to avoid any confusion, if I let y equals to 1 over x, then I can complete the square for this. And I just need to know that y cannot be 0. Any other value is possible. So fast forward completing the square because that is not the most exciting part of this. And you have the following, and therefore the minimum denominator is half. And so your maximum value is 3 over 1/2 equals to 6. Okay, look, this is where I mean that if we talk about easy or difficult paper, I think this is one of the very normal, or even you say slightly easier than normal multiple choice sections. So for someone who is aiming, let's say, for an honorable mention, you say, oh, this is a very easy paper, right? And I think so far, compared to previous years multiple choice, this is perfectly fine. Okay, this continues at least for the first few short answer questions. So let's have good vibes. Let's stay in a good mood as we go through the questions that are not yet difficult by SMO Senior standards and certainly by the standards of this year's paper. Okay. Okay. Question 6. This is standard SMO style trigo as well. I think it's a worthwhile mention, however, that when you're doing your trigo maximum value stuff, There are essentially two main directions you can go. It either goes in the direction of like what we just saw, which is that, oh, it's just there for show, you're meant to complete the square. Or it can be that you are meant to use the identities to force it into something nice. Now, these are what I would call degree 2 trig expressions in sine and cosine. You can consider that to be rigorous or not, but basically sine squared is degree 2, sine times cosine is also degree 2. And when they're all degree 2, you will use your trigo double angle formulas to push everything into just sine and cosine 2x. Right? So of course, we know that this is the sine double angle, and we know that for the cosine double angle, there are choices, but the one that pertains to sine squared is this. Okay, so 64 is 32 sine 2x, and then 48 sine squared x would be 24 times of 1 minus cos 2x. Okay, and then from here, you can use your R formula. The thing about the R formula is that the full R formula is a bit annoying. You always forget, is it tangent inverse A over B, B over A, and all of that. Okay, so let me just write down the R formula statement. This is the default. Of course, with negatives, it changes a little, but the default is this. But the thing is that you only really need to know this, and the R in your R formula stands for range. That's literally what R stands for. So for any questions to do with range on trigo, if it's not just something like, oh, just complete the square just now, if you push it towards this, you will also be fine. Okay, so this, just group it together like that. The range of this is basically from minus r to r, because your sine goes from -1 to 1. And so this is in your 3-4-5 ratio. So this portion goes from -40 to 40. Okay, so of course, to get the maximum value, you pick -40. And answer is 80. Okay, at this point, I want to just also jump in and say that there is always a fair number of questions where you will have some alternative methods. Please feel free to share in the chat. I may not mention all of them. Either I don't mention them because I think that it's actually close enough that it doesn't need to be mentioned separately. Or sometimes it's that like I know that that method is going to show up in a later question. I'm going to mention it anyway. So if you found that the same method is used for more than one question, that is a common feature for the SMO, because different people propose the questions, and sometimes two people may propose questions with the same idea or the same key identity. Okay, so, but I will try not to keep mentioning the same approach, just because this is also a learning resource for some of you who are taking SMO Senior for the first time or second time in 2026, or based on my viewing statistics, I guess someone might be watching this in 2033 or something, if YouTube still exists then. Okay, question 7. Now this is sort of the start of when, as someone who is looking at the paper, I feel like I am very tempted to take a calculator. I usually try not to use a calculator for any of these, because sometimes you get a blind spot, right? If you use a calculator, even if it's just for multiplication, you don't realize how tedious something can be. So there are many aspects of this paper which start to get more, like, I wouldn't even say it as like difficult, but it's just annoying, right? And so stuff like that can be annoying. But without a calculator, what it means is that you are looking for efficient approaches, right? So the first thing is that largest coefficient, you can kind of ignore the x's. Secondly, don't calculate all the coefficients from the front because that is very small, right? Your first coefficient is 1. Third of all, you don't have to calculate 3 to the 8 straight away. The next one is 3 to the 7 times 8 choose 1. Again, I'm just doing the skeletal form of the binomial theorem. Now this is bigger than this because you have just divided by 3, but you have added an 8, so you don't have to calculate the one on top. And likewise, you can continue on. 8 choose 2, 8 choose 2 is equal to 28. So again, 28 is more than 3 times of 8, so this is actually going to be bigger again. And then 3 to the 5 times 8 choose 3 is 56. This is no longer getting bigger because this is times 2, and then if we just check one more, yeah, it's not getting bigger anymore, and after that it goes back down 56, 28, and so on. So you still have to calculate this, but you do not need to calculate the rest. Okay, so 3 to the 6 times 28, 3 to the 6 is 729. If you don't remember it, then just multiply some 3's, and then yeah, this is the point where you just do your multiplication. And a small tip for checking your answers, check things like divisibility tests. Let's say this is obviously divisible by 9. Check that the digit sum is divisible by 9. It is very often when you make a calculation error, you're off by 1 digit, and the chance that your 1 digit was 9 swapped with 0 is very small. Question 8. Now, this is the point where I pull out the same phrase that I've said many times when going through the past papers and the mock papers, right? Which is that you still have to have some trust in the question setter and sort of just ask them, not literally, but ask them, how can you ask me something like this? And then imagine their reply to you, no, it's actually quite nice. There is a trick. Please find the trick. So like all of these so far, you realize that there have been certain features that make it not so bad. This one is certainly one of the more direct ones because you can just see x minus y squared. But you can also see that this one is y squared times x minus y. So it literally just gives you, this is 10 squared, this is 10, y squared is 81, y equals to 9 or minus 9. Hence, they ask you for maximum. If you cannot see an inequality way of doing it, it could just be that there are 2 solutions or 3 solutions, and they ask you to give the biggest one. Okay, so if y is 9, x is 19, if y is negative 9, x is 1, so obviously the maximum is the former. Okay, that follows up in question 9. You ask yourself again, why is this question actually nice? Your answer may be, it's not nice, what are you talking about? It is nice in the sense that if I were to just take one of these numbers and replace it by something else, there's a high chance that it cannot be solved at all. So nice in that sense. The first thing that I notice is that all of these have the same fractional part, right? 2/3, 5/3, 11/3 are just like 2/3, 1 and 2/3, 3 and 2/3. So they are actually kind of just artificially looking scary. And then there's 9x squared, which kind of makes you think, yeah, x is just something over 3. Now, the first thing that I did when I got the paper, when I saw this question, is just guess x equals to 11/3. That's the truth. Because after I realized that everything else is the same fractional part, I'm like, is that going to work nicely? Now, that is the answer, right? And many of you probably got it the same way. It does work. Right, this is 2, this is 5 plus nothing. Yeah, this works. So I cannot hide the fact that this works and it's the most natural thing to do. I would also say that if you have seen some of the previous papers, including I think something from one of my mock papers, you have seen the idea I mentioned for some of these equations, which is that you can guess the answer, but sort of like the back end is that your left hand side is increasing, right hand side is decreasing. And so that's how you know that there are no other answers. Now, of course, you don't need to write this down, right? For SMO, we're not writing our workings, but when I said note this, because there must be a reason why the question setter knows that their answer is the only one, and also expects you to be able to find that out. So if you notice such a feature, where one side is increasing, one side is decreasing, there is a high chance that your method is to do some kind of quasi-binary search to guess. Except that the guess here is kind of the most natural one, because x has to be at least 11/3, and it does work. Okay, there's a lot of questions and a lot of comments in the chat. Please, keep things civil, but feel free to, of course, express your various frustrations. I will look at the chat and answer some of the stuff in a little while, right? We'll do question 10 first. This was one of them with typo, and as I understand it, there was a negative that this typo was pretty quickly remedied, I hope, right? I understand that some schools got like the announcement pretty early on. Of course, I do not know every of your schools, but I think this is not a very harmful typo, right? Because it's quite obvious what the pattern is. It's also quite obvious what the pattern is from the solving perspective again, which is that when you have a long summation of things, I mentioned always 3 approaches. One, there's a famous formula, like let's say the sum of an arithmetic or geometric series. 2, there is a way that you can group things together where each group has something nice. And 3, there is a telescoping sum where everything will cancel out. This is clearly going to be the grouping one. That's why you start and end on plus minus 1/2025. And so it is much better if we were to just kind of check fx and f of negative x algebraically rather than put in any of these weird numbers. Of course, you can put in 1 and -1 just to check your working later, but this is certainly what I would do. Okay. Now, in order to make this combine nicely, I want to have a common denominator, except that it is just attained by multiplying the top and bottom of the second one by 2 to the x. Whereupon these are the same thing. And this is just 2 squared times of the denominator, so that tells you that each pair sums to 4. There are 25 pairs, and there's the 0 in the middle. You can actually just say that f0 plus f0 is 4, so that is 2, or you can put in the x equals to 0 just to make sure that we are not messing up anything, and it is actually 2. All right, so that takes us up to question 10. This is a pretty swift front end, which is why if you were talking about the difficulty of it up to here, it's perfectly fine. But of course, as we all know from experience, the fun starts later. So let's take a 5-minute intermission where I will just read the chat. I'll answer some of the things. You can continue to uh, make your feelings known. And for those of you who join a bit later, yeah, this is what I think the cutoffs are before doing the review. After seeing all your comments, maybe my opinion would change, right? Because the cutoff depends on how you guys do, not based on how hard I think the paper is. Okay, so various things as you guys can be comparing your score. But first, again, feel free to share, right? I mean, that like if you're trying to get some sampling, is just feel free to share. The SMO is something that does reward preparation for things like the first 10 questions. Right? So there's some extent to which if you are well prepared, you will do well. And then there's some extent to which the Olympiad is just inherently unpredictable. The coordinator for each section, junior, senior, and open, is not the same. Right? We aren't even, of course, guaranteed that they will be the same from year to year in the respective sections. So let's learn math, right? The point is that some of these things are to learn math, but every year something weird will happen, right? We had lots of geometry last year, we had a lot of number theory the year before that, and then there is the appearance of calculus stuff, right? It's who knows what's going to appear next? But the thing is that there were no guarantees on what cannot appear, right? The only things that we were assured of is that there will be a significant number of questions in alignment with the school syllabus, which there are, they're mostly in the first 10. Another thing to say, since it's been mentioned, yes, I think question 24 is unsolvable. I'll get to that in a second, but as far as I can tell, I see no reason why there wouldn't be infinitely many solutions. So, and if there are infinitely many solutions, it doesn't seem that they are very easy to generate the infinite set either. And so I would suspect that something has gone wrong with that question. So we'll get to that later, but that is what I have to say about question 24. About the floors and ceilings, why is it some are floors, some are ceiling? Like I said, different people set different questions, right? So I am sorry about the unfortunate incidents that happened with floors and ceilings. We'll say this later, but you know that for the junior paper, they forgot to actually define what floor and ceiling are in the paper at all, and it showed up at question 3. So they have a different problem from us. If anyone happens to have not done an SMO floor and ceiling thing, the different issue at junior. Why is it so computationally heavy? Again, different coordinators, but different people are setting the questions and proposing them too. Every time when you see a floor function somewhere, you just can suspect that the number is not that nice and they did not change the values because perhaps it is to prevent it from being too guessable. Right? That's perhaps the reason. I also would like to say that the first 10 are mostly okay. If let's say out of the remaining 15 questions, you were saying that I really want to solve 5 of them, you would probably be fine. But if you say I would like to solve like 9 or 10 of them, you may end up with less than 5 because you're kind of just in a rising state of panic. This is something that you will get familiar with, and if you are watching this in 2026, then I guess you should have tried some papers and known what kind of realistic score you can aim for. If we overshoot, you'll end up just being fairly miserable and fairly stressed and just jumping all over the place. But it's a learning experience, right? If you're taking senior, it means you can still take open again, so you still have chances to take SMO-like stuff. And I know nothing about how SMO open will be like, except to say that the coordinator for open is not necessarily the same as junior or senior, so you can take no conclusions from this paper for tomorrow. Okay, so these are the various comments in response to various things in the chat. Yeah, senior is inherently allowed to ask anything that is up to the O-level A and E math syllabus. They have just chosen not to ask about calculus. Why? Because they wanted to ask it in open, I guess. But they are allowed to. I mean, a vectors question could well show up in the SMO senior at some point. It just hasn't yet. So, but vectors only up to the O-level most likely could at some point. It's just not today. So, if you're preparing for SMO senior, that is our assumption. Anything up to the level of O-level E and A math content could potentially be necessary. Okay, so here's where the fun begins, or the torture begins, depending on your personal perspective. I feel like if now you just say, forget the SMO, what just happened, and just look at these questions, I feel like this is quite a nice paper. If you're doing it in 2.5 hours, you definitely beg to differ. So let's just separate those two and do math. Question 11. M be the minimum value of this. So earlier on, I mentioned about how for some of these questions, either you will do it in some kind of a way that is with trigo identities push the R formula, or it's just trigo, it's just there, but you're really going to do something else. Now, I see sine 2 theta, I see sine 2 theta. I see cosine to the 4 theta. Now, when I see cosine to the 4 theta, that is not very nice. However, if we are trying to get them to meet, I talked about degree 2 just now, you can get to this cosine to the 4 by moving over the 1 and square it. So that is what I will do. Okay, no more 4, thank you. So sine squared 2 theta and cosine squared 2 theta, there is a 1, there is another 1, and then there is the 2 cosine 2 theta. Okay. This is again the point at which I say that if you wanted to, you could theoretically differentiate it, because your sine 2 theta and cosine 2 theta, you could just replace them by, like, let's say x and root 1 minus x squared, because that's functionally what they are. However, the weird thing about trigo is that it has so many identities that sometimes it's actually nice to keep it in trigo, because it gives us a better chance of figuring out what to do. So I will open up the double angles here. I have no particular preference for which one to use, so I will just stick to the 2 cosine squared minus 1. Okay. And this is actually something that has appeared in a previous paper before. I can't remember from which year, but the idea that we want to prepare for AMGM. In order to prepare for AMGM on sine and cosine, we can try to get rid of the negative, and to get rid of the negative, we basically introduce a sine squared plus cosine squared, so that you will cancel it off, plus everything becomes again degree 2 in our sine and cosine. Okay, so you end up, once you cancel off the 2, and then this is where you can use your AMGM on either you divide, or you can just use it on the numerator, which I think I will. Now, these two can definitely be equal. Sine squared theta over cosine squared theta equals to 5 over 7. It's just tangent theta is the square root of that. That can happen, which is enough for me to know that it's fine. Okay, so this is your minimum. And you're asked for m squared. So it's kind of not surprising that it did not simplify straight away. Okay, question 12. I'm sure that some of you would have asked your teacher whether there's a typo in question 12. I was also pretty curious about that, but as far as we can tell, no, there is no typo. And so massive zooming in to highlight the fact that this is not the same as the other two. Now this is very suspicious, or it could have just no impact at all, right? It is entirely possible that this is just not a typo but irrelevant. However, it is kind of interesting because if you were to look at this, it's not factorizable. And so if it is not factorizable, and I'm just asking you for floor, we just need to get the roots to the, I don't even want to say nearest integer, just the integer part. But I suspect that all of them are going to be pretty close to 0 because x cubed and x squared will be far too big if your modulus of x is too far away. So it could be well that all of them are very close to 0. And what we can do is just to plug in some values to check. Right? So if you put in 0 as our starting point, that's -5. You put in 1, you get -2. Put in 2. Now this is definitely positive, very positive. You have 8 plus 12 minus 2 minus 5 is 13. And beyond that, it is fairly obvious that it's getting bigger, so maybe we just look at the negative side as well. Right, so if you put in -1, you get -1 plus 3 plus 1 minus 5. Put in -2, and some of you are saying, how do I know this is going to work? Well, we don't know for sure, but because they tell you there are 3 distinct roots, we know that for many cubics, it may only have 1 root if the graph looks like that. So the fact that it tells you there are 3 roots, I can just try to look for them. Now this is interesting because we have basically seen the sign change from negative to positive to negative to positive, which means that I already know where the roots are. -2 point something, -1 point something, and 1 point something. And this is enough for the purpose of your floor and absolute value, regardless of what weird order they put it in. Okay, so this is floor of -2 point something is -3. This is the floor of 1 point something. This is absolute value of 1. If any of you, your paper does not have it printed correctly, please complain. Yeah, so correct. This is the intermediate value theorem. I would argue that yeah, the intermediate value theorem is one of those common sense things. So therefore, although it belongs in calculus, it has been used for a long time and no one has ever said they tested calculus. Even AMC 10 tests it. So it's perfectly fine. Now look at the question for what it asks you to do, right? Whenever it's asking you for something like, let's say, absolute values and floors, realize that it is asking you for something less than tell me what they are. So work based on what they ask you. If they're asking you, let's say for the last digit, maybe you can't find the whole thing. If they ask you for the floor, maybe you can't find the exact value. Okay, now this ginormous thing. which clearly was confusing enough that, well, there was the correction made, right, to add in this factorial and the 2025. The question confused whoever proposed it as well. It also confused me because when I first saw the question without the 2025, I can't just assume this was 2025, but then when I saw this, it would be like, no, when this was not there, I'm like, hang on, is this right or is this wrong? And I just skip the question first and move on, right? This is what I would do, and this is probably what you should do as well. You should skip the question first and move on. However, I think this is what most of you did, right? It looks a scary pile of nested summations. Oddly enough, this is actually not that bad. If you guys have ever had to code several nested loops for any programming task, you would know that sometimes there are different ways of writing the nested loops. And this is kind of like one way of just expressing something which is these sum to n, the excluding the factorials. Because they sum to n excluding the factorials, this basically has some truth vibes, right? It's like n factorial over something, 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 something. It is basically, I'm going to say that it is the number of ways to arrange, well, there is K2098 at the end. So it is like there are n minus K1 of item 1, K1 minus K2 of item 2, and so on until K2097 minus K2098 of item 2098 and K2098 of item 2099 in a row. Now, I would be pretty lazy to go and check all of this stuff on the outside, but the fact that it just goes through this entire range is ensuring that the stuff are positive. Basically, all it's saying is that well, non-negative, because K2 can be equal to K1, K3 equals to K2, and so on. So all non-negative, which just means that this is the number of ways to arrange this over all possible combinations of multiplicities. In other words, it's just actually you have n equals to 2025 items. Sorry, 2025 slots. Place any of 2099 items into each slot. And so your big N is nothing more than this. Now, having said that, of course, I'll mention the alternative before we go and take it mod 3000. The alternative can be that you find a pattern, just shrink 2098 down to like 1. And you would be able to kind of figure out that this is just the sum of choosers, which is a bit more well-known. And if it is not well-known, you can see that the sum of 2025 choose K1 is just actually just 1 plus 1 to the power of 2025. So it is then something that you can find a pattern, which is perhaps more likely than to formulate this argument under the SMO time pressure. In any case, this question is also mildly annoying for a second reason, which is that now you need to go and actually take it mod 3000, right? Which is in itself enough to be another SMO problem. So that's a bit annoying. It is probably easiest to go with the binomial theorem approach for this, because everything beyond 2100 squared is divisible by 3000. Okay, you can either calculate and divide, or you can say that this is divisible by 1500 but not by 3000. Right, this one has the 300 and this one has the 5, and so that means that it will be just 1500 mod 3000. Oh, you all want to talk about the typo? Well, the question should probably be one that most of you would skip if there's any consolation. But yeah, this does happen, right? Your your teachers, I think, should have been informed because SMS notifies everyone at the same time. But yeah, I guess it's unfortunate that some of you weren't informed of it. Thankfully, it did not happen for one of the easy questions, right? So that would have been a lot worse. Okay, question 14. This is irrelevant. The only thing that matters is probability P of coming up in an even number. So this is, well, technically it would be a binomial distribution, but that's like an A-level term, right? I mean, probability is something that can be asked for senior as well. So probability that 3 tosses resulted in an odd number in 6 independent tosses of this die is 8 over 225. I guess they had to say biased, but they didn't even have to tell you any of this, right? They could have just said biased die. So that's distracting you. But in reality, what it's saying is that the probability 8 over 225 is 3 evens, 3 odds. Times the number of different arrangements of 3 even, 3 odd, which is 6 choose 3. Okay. So, unfortunately, this is not nice. Yeah, 6 choose 3 is 20. If you divide by 20, yeah, it does not fully simplify. But once again, the question setup is such that that's okay. So you can cube root it and reciprocal it later. And so the funny thing is that there are two solutions, which is Vietas. So you get p squared minus p plus this thing equals to 0. And so although the p clearly is not going to be very nice, you're taking 1 over this and then you are flooring it. Okay, and then we know that 8 cubed is 512, 9 cubed is 729, so this one rounds down to 8. Okay, question 15. Uh, Please skip question 15 if you see something like this, because if you know the method, you know how long it's going to take. If you don't know the method, of course you should skip it anyway, right? So there, you should almost certainly skip it because yeah, it is not something that can be done super efficiently unless you happen to be familiar with like the uh, conic sections. You know, like let's say y equals to x squared, you know the focus and the directrix, how to find it, then you can just rotate the focus and directrix and you know how to convert that back to an equation. If you can do that, which is clearly out of SMO senior content, then the question may not be so bad, but still a bit annoying. If not, then what do we do? Okay, so I need to talk about how to rotate anti-clockwise by 75 degrees in a second. But the idea is that if you have got a point x, y, where y is x squared, you're kind of trying to say that, okay, where does this look like on the new equation? And then after you have gotten the new point, you'll be like saying that, okay, so given that y equals to x squared, what does y prime look like in terms of x prime? This is kind of the task, which is still a little bit like non-trivial. Even if uh, you know how to do the rotation, it is not very nice. I think I will kind of change it a little bit though, because this may not be the best, most pleasant way to go about it. If we were to reverse the direction, maybe that would be better. So in some sense, I want to kind of say that if x and y is here and I rotate clockwise 75 degrees, I need to make sure that my x prime, y prime satisfies this. Let's not use prime because of obvious reasons. Let's just use m and n. So you want n to be equal to m squared after the rotation. Okay, now let's talk about how to rotate. When you are rotating, this is something that I'm not going to use the complex number approach because that would have been easier, but it is for senior. And I'm also not going to assume you already somehow know the formula for rotation. Maybe one or two of you know it from physics or something. basically the idea is that, okay, so this is just talking about rotation, right? Independent of the question for now. If I've just got a point on, I'll scale it down to the unit circle. You know what? Let me just kind of put it somewhere else just so that the rotation looks easier to draw. You are rotating it back, and this will be cosine theta minus 75 degrees, sine theta minus 75 degrees, which can be written in terms of cosine theta and sine theta with now the new annoyance of, what are sine and cosine of 75 degrees again? That's from your compound angle formula. This question is already too long, so I'm just going to say what they are. Okay, so this is what they are. And so you can write the rotated point in terms of the original point. This is sort of like the way that only uses trigo, doesn't use complex numbers, rotation matrices, or all the other fancy stuff. Now I'm going through every question and I'm just going through in order, but before we've really gone anywhere, you're already like, yep, I should have skipped this question. Yes, you should skip this question. Okay, so if we were to call this one's x and y, then that is basically how the rotation is going to look. If it was scaled up by something, if you're not on the unit circle, that will just be a constant factor away, so it would not change anything. So when you go back, after this, you're getting that your new point, which I call M, is cosine 75 degrees x plus sine 75 degrees y. Your new y coordinate is cosine 75 degrees y minus sine 75 degrees x. And so if I now solve for n equals to m squared, it feels pretty awful, but we can tell that there is a good chance it looks like this. One can hope. Right, so let's check. Now this is not a very nice to work on question without a calculator, but I think it's also not a very nice to work on question with a calculator, right? If that helps. So square this. I'm going to fast forward the computations because again, it is ugly enough as it is. 2 times this, root 6 minus root 2 times root 6 plus root 2 is 4. So you end up with plus 1 half xy, and then you will end up with 8 plus 4 root 3 over 16y squared. And well, I see 8 minus 4 root 3 on the x squared, so that's a relief. We can move everything over, multiply by 16, and then that will give you the thing that you want. Okay, so then the answer extraction is to just calculate the sum of all the coefficients basically. So you add up all of this, thankfully some stuff cancels out. So you'll be left with 24 plus 8 root 6. One last computation which you certainly would not like to mess up. And so let me just also double check that I have not messed up myself. No, I think this looks like it is consistent with my answer. Okay, so move this in. This is slightly less than 20, so answer is 43. Did you get 43? No, you got 8 different answers other than 43. Yeah, this is a problem that you really would not want to do. Okay, so that was exhausting. Which is why we went through the first 10 very fast, right? Because of this. But I would say that this is the hardest question in a while. I would say that this is the hardest question, period. This is the hardest question because 24 seems unsolvable. So if you're talking about in the paper, this is probably the hardest one. Another reason why you should not insist on going through the questions in order. Yeah, I don't know how they sort the questions. Like, I mean, that like why the first 10 seem to be easy and then the rest seem to be hard but not in order. I don't know. I do not know why they do not sort them in order. And yes, I do not know why they use ceiling. I'm sorry to bring this up again, but we are now on this question. So I do not know why this is a ceiling while the rest is floor. But this is the sort of question that if you take any of the American team contests, which we as Singaporeans cannot unless you want to form a team, take part in like the contest online and do it at like 4 a.m. together. They have something called a relay round. Right? The relay round is often that like I did it when I was in secondary school. I don't know if it still exists in any inter-school competitions. Right? Relay round is that you have like 3 people in a row. You cannot communicate, and then you just sort of like you each have a question, but the first person has a proper question. The second person says let X be the answer you receive from the first person, and then the third person has a question that says let Y be the answer you receive, and then it's like so you cannot communicate except to pass a small slip of paper saying my answer is this. So if you are the first person and you mess up, then everyone behind you will look at the answer and say this doesn't make sense, and then you can correct yourself. But if you keep on correcting yourself and passing different slips of paper, you will greatly annoy the person behind you, right? And so this is a question that kind of looks like that because the 3 parts are clearly independent of each other. It's just handle a log question, then handle a sum question, then handle another sum question. But they have like no relationship with each other at all. However, if you mess up the first part, everything is going to go wrong. Okay, so first part. The first part is okay because if you have seen the SMO type problems, you know that these always can cancel out if you just make it into a stack of logarithms with the change of base. And I just changed the base to the common log because I'm just preparing them to cancel, so it does not matter. Okay, so everything cancels out. This itself is mn log 2025. So that also cancels. You have just amn equals to mn. So that is step 1. Step 2 asks for the sum of, now what we know is just 2025 times 2 times 3 all the way to 2025 times k. Now that is also not difficult in the sense that you just write it out. Sum from 2 to k is k plus 2 k minus 1 over 2, right? The pairs add up to k plus 2, they are k minus 1 numbers. Then you pass on to t, which is now sum of 1 over sk, where k starts from 2, which is basically a partial fraction question, right? 1 over sk, if we want to just separate that first, is equal to, now these are just two things that differ by 3, right? So in the usual partial fraction fashion, if the difference is 3, then you have to pop out a 1/3. Then you have to sum these, which is just make sure that we get the sum right. I'm not going to write the sum symbol. But this starting from k equals to 2, you will get your first cancellation on the 4. And then the 5 and so on, because it goes on to an infinite sum. Okay, so we calculate this. This is 11 over 6 times 2, so cancel off the 2 and then put this in, and then now we have ceiling of 1 over this thing. It's really like a relay round. It means that like each of these questions individually are sort of like an easy SMO question. But if the easy SMO question is easy in the sense that if each step you have got a 70% chance of figuring it out and calculating correctly, you stack 3 of them together and your chance is like 30%. Right? This is how it works, and then the ceiling is just there at the end to further annoy you. But I would say that the logic in between is not unusual in any way. However, the notation is rather intimidating. Yeah, so the entire point of something like this is that you should sort of be able to tell that, oh, this is what's going on. Plot a path first before you do it. Meaning that like before you actually go and calculate all the numbers, just sort of see what do I think is going to happen for this. Then how do I think this will be nice? How do I think this is nice? If you cannot even figure out what to do with this, then of course please skip the question first. Right? But like at each stage, even before you actually do any of the actual computations, you can sort of tell what kind of thing will happen next. Like the fact that this should be a partial fraction. Stop. Okay, question 17. Now, I have been told of what I think is a fairly inconsequential non-clarification, which is that, see, there are 3 lines, right? The x-axis, there is, now both of these are clearly symmetric and they stop at this 40 over 3. Okay, now I will make them at least look somewhat symmetric. So basically this is just saying find the in radius. Except that I have been told and that yeah, technically you, if someone went to go and find the x radius, that is also correct. Yeah. If you did it algebraically, you will get two solutions. If you did it using quad drop, meaning that you just set the equation to be like, let's say, yeah, your center to have like be x is 0, and then like you did this, you will get a solution. And if let's say that you happen to have tried this, you may end up a second solution if you did the quad drop and discriminant style. However, I think that it is pretty natural that if we are doing this question, most of us are going to think of the in circle, whether you did it algebraically or geometrically. And so therefore, I cannot tell you for certain whether they will accept the X circle thing, but you are not going to be finding too many people who assumed it was the X circle. Okay, so I just want to point that out first in case anyone thought of that X circle. So the thing is that I believe the question is meant to just refer to the in circle. I believe that if it has been noted, then maybe if you have got the X circle, the answer, you will also be accepted, right? There's, generally, these things do get accepted if it is found out that there is a reasonable alternative interpretation. But I'm just going to do the in circle version, which is that your area equals to half times base times height equals to RS, where of course half times base times height is easy enough. S is your semi-perimeter, which is, because this is in a 3-4-5 ratio, the semi-perimeter, you can just take this portion. So 50 over 3 plus 10, which is 80 over 3. Okay, and then this will give you the in radius is 5, which, as some of you mentioned, yeah, is kind of a relief after a pile of algebra in question 16 and an even bigger pile of algebra in question 15. Okay, so I think this is a good point for us to take our second break, because the last 8 questions, they are weirdly actually not that bad, but they are bad in certain ways. But like as a whole, it's not so bad. But we can take a quick breather. So, more questions, feel free to ask. If you have any questions about how the SMO is actually going to give marks, I don't know for sure, right? But what I know is that feedback will be given by some of your teachers if they find out, and then the SMS will consider it accordingly. This is what I can say. Two more circles. Oh yeah, that's true. There are more X circles, right? So let's just say X circle since, yeah. Area equals to RS. It basically has got these are the equivalent formulas for X radii, where RA is for the X circle opposite, sorry, the X circle which is outside of the side A. So you can get the length from there, yeah, and yeah, that's true, right? You can actually have more circles on the outside. Yeah, I trust that it will be taken care of. Cutoffs, again, I generally, because of the fact that the cutoffs have not like shifted by more than like 2 or 3 points. So if I'm guessing in the middle of the range, I mean like it will always be plus or minus two, uh, to a high degree of certainty. But there are things like this now, means that I don't know. Like let's say question 17. Are they going to accept alternative answers or are they going to avoid the question? I don't know. I mean, I'm not involved in the decision making. But if let's say that it's up to me, I think I'll accept the alternative answer and not void the question. However, if they do void the question, of course, that will change how it affects everybody, right? So there's some of these uncontrollable things. Yeah, void the question just means that either everyone gets 1 point or everyone doesn't get 1 point. And that's the thing, right? So if everyone gets zero and the paper is out 24 and everyone gets one, effectively that's the same outcome. But in terms of the actual cutoff score, that changes by one. And so when we talk about cutoff scores, there's also that kind of issue. Like, do you count it as everyone gets 1 mark or do you not? Which has no difference in impact, but has difference in what you declare the cutoff to be. Um, Official solutions will be there once the SMO solution book is published, which is usually it will be sold at the prize presentation in the September holiday. So that will you will see the book lah, meaning that whether they say that this question was voided, or do they say that this or this answer, or like, or do they just make a correction to the question? I mean, we will see. Round two name list often will come out in a couple of weeks' time. That is when the cutoff is never officially announced, but we kind of can infer. So like that is always also depending on you guys. If you report your scores accurately and someone says that I got 12 and I got in, and another one says I got 11 and didn't get in, then we know the cutoff was 12. But it is impossible to be certain that yeah, I mean that sometimes I hear someone say I got 12, I didn't get in. Someone says I got 11, I got in. Then I'm like, huh? Because somebody may have shaded something wrongly or stuff like that. So, we're always just guesstimating. SMO books, there's usually I'm not actually sure like when and where it is. You can ask your school teachers. Normally, your schools will carry some. Of course, if you are invited to the prize presentation as top 30 school representative, SMPF winner, essay competition winner, or whatever else, then of course you can buy it when you're there. I think if you are from NUS High, often you will be roped in to help. If the presentation is done in NUS High, then maybe you can just also like, even though you're the helper, you can also buy the book. Other than that, it should be in the NUS Co-op, the bookstore at the science faculty, and I am not too sure where else. It's not 100% certain. Yeah, typos do happen. Like if you guys see the mock papers that I said, right? I do vet it. I would like to think that my mock papers are of decent quality. But there will still be typos. Hopefully they are small. Like let's say one of them I forgot to I sort of said positive integer, but I included zero. Like that kind of thing can sometimes be like it's clearly that you either include or exclude. I can accept two answers, but yeah, typos do happen. So um, it is pretty difficult to scrub everything. I'm sure they do their best. Yeah, again, the name list, so you will probably find out from your schools. However, it will also be out on the website. Sometimes it's out on the website slightly before they inform the school, sometimes slightly after. Nonetheless, it should be out in a couple of weeks' time. All right, let's get going. Partially because I still have not finished typing the junior questions. Right? I need to type them out. I mean, I have them solved, but I need to type them out to prepare for the evening stream at 7 p.m. for junior. So if some of you are from junior and you're sitting in, of course, go and have your dinner and then you can join in at 7. If you guys are taking the SMO Open tomorrow again, all the best. And if you're taking junior and open tomorrow, you can always just like pop out of the thing like halfway if you need to sleep a bit earlier. Okay? The junior questions are not really perfectly in ascending order of difficulty. Maybe the ones like that you need could some of them be in front, not necessarily the ones behind. Okay, let's come back. This is a Venn diagram question. It's a Venn diagram question, not in the sense that we need to do anything special with the Venn diagram. It is more that we need to draw the Venn diagram. Otherwise, there is no reasonable way that we can keep track of all of this. In fact, let me just double check I've typed it correctly again. I think so, because there are too many primes, which is another feature of this paper. Too many primes. Venn diagram. It's not a normal Venn diagram. We can draw that universal set thing. This is your 1 to 7. A, B, C are all sitting inside it, but A and C don't intersect. So it's actually a chain. And 1, 2, 3, 4 are in A intersect B, union B intersect C. So this shaded. That is your A intersect B and B intersect C. You have all the rest of these, which you just kind of need to read off and just find the region, right? So not in A and not in B and not in C is outside. A but not in B. Not in B but in C. Not in A and B but, sorry, not in A and C but in B. That's just everything, right? That's just all the regions. So essentially, there are just 6 regions where the first two, I will just move the page break because I think, so the line break, because I think this is a bit hard to see. These two just share 1, 2, 3, 4. The other 4 share 5, 6, 7. Now that simply means that 1, 2, 3, and 4 each have 2 choices. 5, 6, and 7 each have 4 choices. 4 cubed, not 3 to the 4, sorry. So 3 numbers with 4 choices each. So 4 times 4 times 4. 4 numbers with 2 choices each, so 2 to the 4. That's it. The latest iteration of it sounds really complicated, but it's actually not so bad. Okay, question 19. Also known as like kind of like the only actual geometry question after last year's inundation of geometry questions, right? And this is why if you're watching in 2026, please do not assume that the paper will only have one geometry question. Just like if you're watching last year's one and you assume there's going to be a lot of geometry, that did not happen. For geometry questions, please remember to read the question and not just the numerical stuff. Read the words. I know that sounds borderline like just insulting your intelligence, but no, seriously, read the words, right? Because if let's say some of you didn't read, then you thought that O is just this point here, and then you didn't realize that this is the center of the small circle, then of course you are stuck. O is the center of the circle, the smaller circle. Some of you did not read the tangent to the bigger circle, because maybe in this diagram, you may argue it looks like it's going to intersect again. It's the tangent line, so just read the question. Okay, now based on this, if you have not used the tangent at any point, and you have not used the O is the center of that circle at any point, then unsurprisingly, we would not be correct. Okay, let me just make this diagram a bit bigger lah. Right? You can't resize the diagram in the SMO, but I can, so I shall. You can draw your own one, but I shall resize it here. Yeah, so then you can see low quality image. Yeah, I did not draw it myself. This is from the scanned copy from the paper. PRS is 20 degrees. That is given. I'm drawing this here because the isosceles triangle, so that's 20 degrees. And then if you have your alternate segment, it will tell you that this is 20 degrees. Which means that, yeah, the diagram's not to scale. But it's not surprising it's not to scale because the thing doesn't really look perfectly like a tangent either. Okay, the alternate segment or an additional copy of angles in the same segment would also give a 20 degree here, would also give a 20 degree here. So what are we doing? We are trying to find SPQ. We have enough already, right? So actually after labeling all of that, then you realize that I don't need to do anything else because this triangle here, 20, 20, 20, 20, and then SPQ is the rest. And so all the isosceles triangles that may or may not look isosceles, similar triangles that may or may not look similar, we don't have to worry about that. As a general rule of thumb, if only one numerical angle is given, then this must be just a function of the other angle. So if you don't like 20 degrees, because it's not a special angle, then you can just treat it as theta and mark out all the other locations where it appears. Right? That's how we angle change, right? Mark out every other appearance of that same angle. Okay, question 20. This is kind of a special case of van der Mon's identity. I'm just going to explain how does van der Mon's identity work, but if you say that I did not actually know this identity, the truth is that this pattern is not going to be very easy to find. And I say the pattern meaning that if you say that I shrink down 2024 and 2025 and start looking, that is quite tricky. However, it is potentially possible for you to find a pattern for the ratio, because you will find that as you just pick replace 2024 and 2025 by let's say 3, 4, 5, 6 or so on that are still reasonably sized, you can potentially see how the ratio appears to converge. Okay, so that's the technically low powered way of getting the answer. But I think where van der Mon's identity comes from is pretty interesting. This is just a case of it, but it explains the general as well, so we'll do that. 2025 choose I squared, I will use that as the example. And how I will do it is that I will just replace one of them by 2025 minus I. Now this is sort of another combinatorial interpretation like we had for that pretty ghastly looking question 13 with the nested sums. This is understood as there are two groups of 2025 items. You pick some number of them from the first one, and you pick 2025, means that you pick a total of 2025 where you can pick any number from the first group and any number from the second group. So let's say if you want, you can pick this, and then after that this is I, and you can just pick any other stuff. Visually, of course, it can look like that if you want to align it like that, but can be anything. So Therefore, this is just going to be 4050 choose 2025. And Van der Mont's identity is just sort of telling you that this is how things work. Right? So same with B being then 4048 choose 2024. There's no identity for the ratio of these, but you can write out the factorials because they are close enough to each other that they are definitely going to cancel. However, like I said, finding, let's say, the pattern to be 4 choose 2, 6 choose 3, 8 choose 4, 10 choose 5 is a pretty difficult pattern to find. So, like I said, the ratios may give a pattern, but the value is a bit hard to determine. Okay, so 4050 over 4048 factorial, I have two of these on top. And then I've got two extra 2025s below. So this is a little bit less than 4. Okay, so last year we sort of had a lot of geom configurations, right? For 2024, like all the geom configurations, like shooting lemma. What is the shooting lemma, right? Some of you ask, and I'm like, okay, I can tell you what the shooting lemma is, but let's be honest, nobody is going to just think of the shooting lemma in a contest. However, the explanation is pretty cool. Then after that, it's like we have Pell's equation. Who is going to think of Pell's equation if you've never seen it before? It's an undergraduate number theory topic, right? But if you have seen it before, you just apply. Now, the same applies to, let's say, this Van der Mont's identity, but the difference is that at least I can explain to you from a intuitive perspective why it is true. But you are certainly not expected to figure this out yourself. What you are expected to figure out yourself is question 21. Please do not go in order and like miss out a question like this. All right. This is the reason also why it's very hard for me to talk about cutoff predictions, because I cannot predict what percentage of you would have gone in order and forgot to see this question. So I mean, that will also impact things. Right? I cannot tell. But anyway, for anyone who did not solve this, please don't like laugh at each other and all. Like personally, I use trivia as an adjective, but not an insult. If you have not seen any idea before, nothing is easy. That's a fact. But this is such a common idea that you have a much higher likelihood of having seen this before. So the simple answer is that both of these are going to be half the area of the rectangle, regardless of the location of P, right? Because it's just up to you how you want to justify it, but you can just say that it is half times base times height on both sides. So it is actually invariant at 2025. Okay, let's move on. I have nothing else to say about that. Calculus. Now this is the next kind of I wouldn't say controversy, but the next thing that makes it very hard for me to tell a cutoff, which is that if you are doing this question, this kind of is like a two-parter, right? Do you know how differentiation works, product rule, and then do you know Wilson's theorem? Both of those are very fixed things, but there is a high likelihood that you may know one but not the other because they are very fixed things. So if you know them, condition on your knowledge, this is easy. F prime of 2027. So I have to just assume knowledge of calculus. I'm not going to teach calculus now. So F prime of 2027, if you basically just break it up here, it will be the derivative of all the stuff in front times the x minus 2027 on the outside plus all the stuff on the outside times the derivative of x minus 2027, but of course that is 1. And so therefore when you sub in 2027, the first one disappears, the second one just becomes 2026 factorial. Oh yeah, there's one more thing. You need to check whether 2027 is prime, right? 27 is prime. It is near enough to the year 2025 that I think some of you have Googled it in advance. But if you didn't know, it is basically that it's either that it is prime or it is the answer is 0. So yeah, by Wilson's theorem, yeah, what's Wilson's theorem? Very simply, just p minus 1 factorial is congruent to negative 1 mod p for primes p. That's all it says. Very specific statement. So of course your answer is not negative. The remainder goes back up to 2026. But you do need to verify that 2027 is prime, or you need to have Googled it in advance. Maybe this is useful for open tomorrow. I'm saying this with no knowledge. If it turns out that it's useful that 2027 is prime tomorrow, that is purely coincidental. Okay, question 23. I feel like this was almost explicitly in an open paper from one of the last few years, except of course without the number 2026, but almost identical to this in one of the last few years. The fractional part, we know what the fractional part is. So therefore, this is just going to be the integral from 0 to 2026 is 2026 copies of the integral from 0 to 1. And if you know what the integral symbol means, of course, fine. If you don't know, you can't do it. But if you know what it means, you can either do it geometrically because it's just integral of x, or you can do it by taking the antiderivative. Let's just mention it like without assuming knowledge of calculus beyond the symbol. This just means area under the graph from 0 to 2026, right? So your fractional part graph just looks like this. And when you're talking about the area underneath it, it just means this, like this. That's just what it means. And then you have 2026 of that. So this area is clearly 1/2. It's just half times 1 times 1. Yeah, so about calculus, it is something that has not appeared in like the recent SMO seniors, or in fact any SMO seniors I'm aware of. But I mentioned earlier, right? As long as something is part of the O-level syllabus, technically the SMS has the right to use that as sort of a curriculum linked question. I mean, things like number theory are not in the curriculum, so you cannot complain about the existence of number theory. You cannot complain about the existence of combi because that's explicitly not. But for like the curriculum linked portion, things like that, now we know, then I guess calculus becomes something that is useful to be aware of. Not just as like a backup tool, but as something that could literally be asked in a question. All right, let's talk about question 24. as far as I know, no one has told me otherwise. But for me, I am quite certain that there are infinitely many solutions. But if there are not, it doesn't seem to have a simple way of being handled. Let me explain some of the things that I considered. Okay, so things that I considered that did not work, so that you know what I have ruled out. Firstly, so what doesn't work? Yeah, so I think this will be voided, right? This is like, if let's say it is infinitely many solutions, it's definitely going to be voided. But I'm saying right now, I do not have time to go and prove whether a question is wrong. Right? I can think a question is wrong, I can't prove a question is wrong. So what doesn't work? Firstly, you can't mod anything. There is no way that you can mod anything nicely, as far as I can tell. Secondly, if let's say that you just let this thing be, let's say a times q squared minus 2p, sorry, this is q squared minus 2q, right? And then try some quadratic stuff. I tried to think of some quadratic stuff, meaning your discriminants and all didn't seem to work, at least not in a reasonable time frame. Bounding doesn't seem to work because you can just let p be big, and that doesn't have anything that seems to go wrong, right? You just know that because the denominators doesn't seem to give too much issue, p just needs to be less than q squared, right? P can be big. So there is no reason why like p and q have to be small, or that like they have to be close together. I considered Vieta jumping, yes, but I do not have time to check Vieta jumping. If somebody wants to go and check Vieta jumping, you can, but certainly if it needs Vieta jumping for a senior round 1 question, it is definitely wrong. That is definitely not the intention. Yeah, so this don't work. If you tried some Euclidean like stuff, that also doesn't work. Now all of these are already things that I'll be using in a round 2 question, right? So I'm fairly prepared to say that this is definitely either wrong or way too hard. And if in between now and the round 2, not round 2, between now and the junior paper review later, if I figure out something, I would tell you. But if you figure out something, just feel free to share. Yeah, I tried some small cases and there are a lot of solutions, meaning that there are a large number of solutions which do not seem to have any reason why they would stop. That's all I can say. Okay, so we will see. Right? Is probably where I'll leave this, and of course, if something comes to mind, minimally, it's an extremely hard question. At worst, there was some missing condition, or I'm not sure what else. But minimally, it's extremely difficult, and yeah, if nobody like I do trust the wisdom of the crowd, right? So if nobody in the senior or national team, people who have tried it, can solve it, that in itself is enough statistical evidence to me. Of course, if somebody has solved it, please tell me. Okay, and so we and properly on question 25, which is not the hardest question. If anything, it's actually quite a frequently seen SMO idea, right? The cyclic substitutions, but I have to say that the choice of values is pretty novel. It's not the usual combination of stuff. But it's very like if I were to contrast 24 and 25, right, is that when we are doing a round one question, we must treat it like a round one question. I think none of you ran out of questions to do, right? You all like ran out of ideas, or you ran out of energy, or you ran out of time. When you're looking at the questions, you do want to assume that they have like a round one level kind of trick, which in this case is just substitute in values and see what happens. You have to take that assumption, because if again you just tweak the numbers a little bit, it could become very, very hard. Or for something like this, if I just change, like I swap one of the P and Q, suddenly it will become very easy. So we'll see what happens with that. But for this, I'm just going to let x equals to 0 since you asked me for g of 0. It's pretty easy to substitute. So that's x equals to 0. I don't really see any reason to do something else other than sub in 3 and 3 over 2. And you see this loops around, so you can be fairly certain that one further substitution will work well. Okay, now this is going to be those three values, which is great. And now you end up with basically a simultaneous equation thing where it is effectively the same as if it were addition instead of multiplication. Except that I feel like I want to log both sides, but I can't because I don't actually know whether the g at these values are positive or negative. Okay, so since I can't be sure of that, I will just leave it as it is and do the normal kinds of elimination to get g of 0. Okay, so we eliminate g of 3/2, I guess. We don't like fractions. So for the first two, this is fairly funny to write, I would say, to have dividing and taking powers of equations. Not every day we see that. We can eliminate this. You end up with g3 times g0 to the 19 equals to 7 to the 5. Okay, and then we can repeat this with 2 and 3, where I will eliminate, I'll do 1 and 3 because then I'd have 1 down there. Okay, so this eliminates g of 3 over 2. You have got g of 0 to the power of 11 times g3 to the power of 19 as well. Okay, and then you can eliminate the g of 3 by taking the 19th power and then dividing. Okay, answer extraction is asking for it to be in the form of P and Q being prime, which we can certainly do with this being 2 to the 10 instead. At which point you can tell that 95 over 350, I'm not even simplifying it, plus 1 over 35 is less than 1. So if it's ceiling of the sum of everything, the answer is 10, which could kind of be semi-guessed because you do know that the P and Q almost certainly, once you see this, would be 7 and 2. Great. Now, this is very weird because we have talked about this is quite a difficult paper, and it is for the back half. But it's difficult for all kinds of weird reasons, which is why we're done in like 2 hours, even though normally senior takes 2.5, right? Last year took 2.5. This year I've been talking a lot, and it takes a much shorter time. Now, just to kind of ask you now, you can share, what do you think the cutoff will be? After seeing the review, have your mind changed? Because for me, I feel like the psychological impact plus all the calculations may skew things a bit more. Like in terms of actual difficulty of the questions, like I feel like a cutoff of like 15 in terms of difficulty is fine. There are 15 questions that can be done. However, of course, if the void questions are given to everyone. But I don't know. Is that going to make a difference? That's why I say I'm not thinking the score is 15. I'm saying that if not for all the careless mistake prone questions and the fact that there was a question that's potentially erroneous, the actual baseline difficulty of the paper is fine. So it's pretty hard to say. Yeah, there's obviously plenty of different opinions on this, right? But yeah, what I would say for all of you guys is that you have different targets, right? We talked about a round 2 cutoff. Not all of you are aiming for round 2 because round 2 is hard, round 2 is scary, round 2 is fun, but certainly not if you just get tossed in there. So regardless of whether you think your chances are good or not good, do take the time to go and look at some round 2 questions. Look at them. If you have no experience at all, read the question, think about it for 5 minutes, read the proof, and then for recent years, you can look at my videos as well. Try to read before you actually think about solving if you're less familiar, even if you think you have no chance of getting to round 2. Because if you suddenly get in next year, then you are going to not want to find out 10 days before round 2. So comparing the difficulty one last time, right, is that I feel like for this year, it is easier than last year to get 10. So some of you who are my students, I sort of said this, I'm quite consistent. It felt easier than last year to get 10, but it felt like getting beyond 15 is really hard compared to last year. Right? Meaning that like it is such that there are, well, again, depending on how you consider these potentially void questions, there are weird oddities like calculus as well, right, which can swing. Because if you have familiar with calculus, there's 2 more easy questions. If you are not familiar with calculus, then you're basically now doing a paper out of 21, minus 2 calculus questions, minus at least 1 voided question, and minus like something like question 15 that in practice is almost way too hard, right? So it's really hard to compare. Okay, yeah, so I don't really have too many specific things to say. Feel free to stick around if you have some questions, and if not, if you're taking open, all the best. Do get some enough sleep. Don't try to cram, although I can see from the viewing statistics that people are currently looking at the open round, open 2024 last year now and desperately cramming it. For open, we don't know how it's going to be like, but the same as this, right? So look through the whole paper first, please. If it does look like the first 10 are a lot easier than the rest, then especially for open, be willing to focus a lot of attention on 10 questions. However, if it does look like there are some easier questions behind, please do try them, because the thing about open is that it has a wider range of topics. And so it's a wider range of topics for open than senior, which means that sometimes there will be more like primary school style questions too, along with some extremely difficult questions, right? It's a wider range, so you can think of it as higher average difficulty but higher variance as well. Means that the easiest few questions may even be easier than the senior questions sometimes, because the senior questions, the easy ones here, are all power of algebra, whereas you may have some standard easy questions for open sometimes. or it may turn out to be a part of algebra again. So please don't take anything I say as definite. Just that for open, do look at the whole paper, because from year to year, just like senior, it changes a lot. Yeah, so what do I think the actual cutoffs will be? Based on what all of you have shared also, I think I will stick to this, but now I will just add on the remark that this is sort of if like your void questions are 0, right? So which means that 24, if it is voided, I'm counting it as the paper is out 24. If question 17, I'm also counting it as, let's say, it's zeroed out, then maybe this is cut off potentially. If let's say that they give everyone the points, then obviously it may increase. And I would say that, of course, for question 17, if they accept 2 answers or something, then yeah, it can maybe just drift it up by 1, because many people would have been able to find one of the answers for 17. It is also not guaranteed that the gap between the silver, bronze, all of these are 2. It is possible because of the fact that the papers easy questions are very bunched. There has been 1 mark boundaries for awards before, right? So I feel like it's entirely possible to have something like a silver cutoff of like 10, and then it can go like 8 and 7, right? It means that it may not be too apart. If there are a lot of people who score exactly 7 or exactly 8 or exactly 9, such things can happen too, which I feel may happen for this year, because like there are at least like 5 multiple choice that are fine and some other questions which are relatively easy. That may happen. It's not guaranteed 2 marks. It's just that often, in order to have a significant number of people in each award, they normally will have 2 different scores in the honorable mention, bronze and silver range, right? It's not guaranteed. It can always change. So that's what I would have to say is the potential change. But I think I'm going to stick to like whatever score I mentioned just now. We did, of course, run through the paper in like 2 hours, but a huge amount of that time was spent on 3 or 4 annoying questions. So it's kind of like yeah, I think it's not difficult to, let's say, like for the better students who let's say have seen a lot of the questions before, to be done with, let's say, 10 questions, not necessarily the first 10. You can have like 10 questions done in 20 minutes, possibly, right? So it can happen. But that does not mean that the rest of the time will be very useful for them. It depends. So this is what may also cause things to be shaken up a little bit. Okay, so yeah, I'll leave the stream on for like 5 more minutes or so. If you want to chat a little, I'm not going to moderate the chat too much. And yeah, you are welcome to join the junior one if you took junior, or if you just want to see what your juniors did for junior. You can take a look. I think the junior paper is also has some interesting features, but it is definitely not as exotic as the senior one. Yeah. Okay, so I'll go off camera first, and I will get some water, and I will see some of you back either tonight or tomorrow.